Hello viewers, welcome back to video tutorial on AgentGrid. In this video, we'll be discussing very important concept in our entire video demos. So that's nothing but the metrics or observability. So in our AgentGrid, we have integrated very comprehensive observability stack to monitor the system health or pod health or any other health or metrics, and also to simplify our troubleshooting during your day-to-day application building in AgentGrid. So this observability stack will definitely help you. So before getting into details about observability stack, so I request users to go and check our other two videos that was created for the service grid. One was related to tools and one was related to functions. So we have taken those code as a base and we have added our things required for the metrics demonstration. So for performance metrics evaluation or performance metrics, if you want to watch it or you want to check your metrics of your system, then we have integrated the industry standard infrastructures like Prometheus and Grafana. Prometheus is used to collect and store the real-time system or performance metrics that you push from your agent code, whereas Grafana UI, you can use it for visualization and real-time dashboards. So this is related to the metrics, and for logging, we have a Grafana Loki and Grafana Explore page. So where Loki aggregates and indexes the container and pod logs, and whereas you can use the Explore section of the Grafana tool for visualizing or a post-mortem analysis of your issues that you face or anything that you have logged. You can watch it in the Grafana Explore. So in this video, we'll be talking about only the metrics. So in the next video, we'll talk about the Grafana, the logging. So as I told you, have to watch the previous videos because we have taken the same code examples. So let us get into the codes. So for the Prometheus metrics, so we have added one important file in our SDK. So you have to go to core and you have to go to metrics.py, and one other file that we have added. This is in a library itself, so you don't have to download it anywhere. So it is in the library code. And one other important utility we have added right now within service grid example, I have added one other utility known as metrics.util. So we'll discuss about these two files first. So this metrics.py, which was in the core folder, which was in SDK, basically it uses the Prometheus client Python SDK, and it has a Python SDK has certain primitives, counters, gauges, histogram, where counters is basically it's always an increasing number, it will never go down, and gauge is nothing but you have like up and down, like a fluctuating values, you can give it as a gauge. The histogram is basically bucketing, wherever you want to handle the response times, right? Histogram P90 or P99, you want to know that, so you can use the histogram. So summary, info, enum are certain other primitives of Prometheus, which will be using it in our the our usage. And we have other like start HTTP server, collection registry. These are the certain imports that we have done, which we'll be using in the later stages. So there is a class known as metrics registry. Basically, we are doing some initializations with the namespace that you are sent from the agent code. So by default, the agent is the namespace, and you are creating a collection registry. So if you are sending some registry, we are using that, or else we'll create a registry here. So basically, what we are doing is in this file, we by using the primitives of the Prometheus, we are creating some sort of a functions that can be used later on. Let's say a counter is a function, inc is a function, gauge is a function, set gauge is a function. So these functions will take these primitives and do their task accordingly. Let's say this counter is for creating a new counter variable, and inc is for increment, so basically to increment that counter value. So all these functions are available here, and let's say gauge, set gauge, increment the gauge, decrement the gauge, because the gauge is a fluctuating value, right? So you can have an increment and gauge. Then histogram, so you have to create the buckets and you have to give the buckets details to the histogram, and observe histogram basically dump the value into the buckets. That's what the observe histogram does. You can create a summary, observe summary, info or set info, and enums, and set any enum value. So these are certain primitive libraries, functions we have in this particular file. and also related to histogram, time histogram, or time summary. So this is for a if you are doing with context, right? So that's why we have given a context manager. You can always use a with, so that will help you in I mean, you don't have to create a start and end. You just have to create a with, and in that with you have to wrap all the code. So we'll see it in later stages. So time histogram, time summary, so that you will measure the wall clocks, and you will record those observations in the observe histogram. So we'll see the usage of this function. And we have again we have a tracer as well. So trace, you want to see how much time is spent in each function, or a sub function, or agents, right? So in such cases we have a tracer here. So for tracer, there's a span class which we'll be using, which is basically a single trace span. And we have a actual tracer class here. That tracer class uses the span here. Span has a end time and start time. So we'll use this particular class to start and end one particular span. So let's say you have a for agent code, you have some 2-3 functions. You want to monitor those functions. Basically we'll create a 2-3 spans, named spans. So this tracer, we have a start span and finish span functions. And again, if in case you want to use explicitly, but if you don't want to call these functions explicitly, then we can use a context manager. So you just create a span, and it will take care of calling the finish span and start span. So basically I'm using these functions here created above, and I'm using it here. So and also we have a start server, a start metric server, which will again use the start HTTP server. And get registry and get tracer are the two more functions we have, which we'll be using it in our metrics util. So basically this file metrics.py provides you a basic the functions required by you to utilize in a higher level of functions. So this you don't have to modify anything in this file, because it's provided in the library. So unless you require any new kinds of functions, or functions are required to modify any of these values, then only you can touch this file. So we have something known as one other intermediary file, metrics util.py. So this you can modify according to your requirements. So let's say right now I'm monitoring the metrics of the agent. So I'm just noting down as a agent metrics, and I'm importing those functions, the 3 functions: get registry, get tracer, and start metric server. So what is start metric server does is it starts an HTTP server within this agent pod, wherever this is running, right? So it will start one HTTP server, and that server will be running by default in 9090 port. And this server will host a slash metrics endpoint, and in that slash metrics endpoint, all the time the whatever the metrics you are going to do will be available for access. And the Prometheus will try to connect to that slash 9090 uh, port of this particular pod, and it will try to collect all the metrics in periodically, and it will retain its it will keep those content indexed in the Prometheus, so that Grafana later on can use it. So the start metrics server is and get register and get tracers are reported in the metrics util function, and we are initializing those, like say start metrics server and registry and tracer. So do these objects are in, I mean, basically the call of these functions are initialized, the function objects are created, and then I have one important function here known as register agent metrics. So in this agent metrics, I'm creating some information and enum value. The enum value is agent state, and the info is basically it's the agent identity, static identification, identity information of the agent. You can create any details. Right now, I have not put the details. I just this is just the key to create. This is the key to create. Again, here enum, this is the key, this is the key, and this is the description of the key. If you go to our get enum, right? So we have a enum. So info, you require a name and doc, and enum also you require a name, a doc, and the states. It's a list of strings. And also if you have a labels, you can provide a labels. So right now this enum has only states. There is no labels for it. So states, it can handle 4 states: initializing, ready, processing, error, 4 states, and this is known as agent state. So anytime, whenever we are setting up a state, you need to use this agent state, and you have to give only either of these values. So agent identity is just the information that I have not set value content at. It is just that this variable is created. And also I'm calling some more sub functions: register preprocess metrics, on data metrics, tool call metrics, function call metrics, and LLM call metrics. So let us see what is this preprocess metrics function is. It is defined here. Preprocess metrics. So I'm registering some counters here of 3 counters and one histogram. And in the 3 counters, one is preprocess skip total, preprocess error total, and preprocess total. So skipped is like how many preprocess has been skipped, how many errors are recorded, and how many totally successful implementation of preprocess has been done. So that's what these 3 counters are. And also I'm giving a label to it. If you go to counter, if you go to counters, you will see a name, doc string, and label. So doc is just a generic information. So name, doc, and the labels. So basically when you create this label with 4 arrays, right, so it's a 3 content here, whenever you are registering your value for this variable, it will create basically 3 kind of a column. So reason column, user task id column, and task id column. Whenever you are going to dump the content, so basically it will get these 3 columns also will be needs to be set. So what is the reason, what is the user task id, and what is the task id? This value also will be set for this particular one key. So let's say you have one reason, you can have multiple reasons. So basically you will create a multiple reason columns. I mean, you will, in a reason column you will have multiple values, so that when you are doing a search in your Grafana tool, you can use this labels as well to search. Let's say the let's say it is skipped, right? So skipped can be multiple reasons might be there. What is the reason of that? So if you want to specifically check what all different reasons are there when it is getting skipped, so you can check it in Grafana using this particular label. Similarly, for errors also, you have a exception. What is the exception message maybe, or exception key, like value error, or a out of bound, or a zero error, or anything. So such kind of exceptions keys can be captured with this particular label. So again, we have a user task id, and exception. Whereas preprocess total, we have a user task id and task id. And the histogram, this is the histogram name, agent preprocess duration seconds, again a doc, again a label, and we have a custom bucket. So these are the current buckets that I have kept. But when you are test running it, if in case you want to add some more bucket details, you can add the bucket. Or if you want to reduce certain details, you can reduce it, because every bucket or every extra bucket you add, it will definitely take some disk space, because this content has to be stored for every, let's say every second it is pulling the data. You creating this, let's say 10 buckets. So if you are, instead of 10 bucket, you have a 15 bucket, then in a second, just 5, because of 5 bucket extra disk space will be consumed. So you need to think about your whole 1 month duration, disk duration, or 1 day disk usage. So according to that, you need to configure this disk size as well. So right now, for example, maybe 8 to 10 buckets are there in this. And basically the Prometheus will add one other extra bucket, which is after this, and which is nothing but 600 to infinity. So we have a histogram here, and this is for preprocess matrix. Similarly, I have a on data matrix. Again, I have a gauge here, which is nothing but activated task, whether it is processing or not. Maybe since it's a gauge, it will go up and down. And the counter value, what is the total number of tasks processed, and again a histogram, so which is nothing but the response durations of the on data, how much time it took. So again, we have a bucket here. So here also I have a action exception user task id, and here also I have a action exception user task id. So similarly, tool call metrics. So how many tool calls are done, how many tool calls are ended up with errors, and what is the total tool call duration. And also similarly for functions, I have what is the total number of functions we have done, call we have done, or how many are error functions, function call. And also a histogram, what is the time it took for a function call. So then in this function, the labels are function id, whereas in tool we have a tool id as one other label. Rest all labels remains very much same. And we have a LLM calls. So how many LLM calls total you did, what all are the total, how many are ended up in errors, what is the total of prompt tokens, and what is the completion token. So and also what is the total token. So if you want these details, so I have a counters registered for that, and also have a LLM call duration, so that you can use it to break it exactly, like what took how much time, like whether it's a time, though one data took so much time, it is because of what, so internal processing or LLM calls or what, so whether tool call. So for such details I have provided this. So if in case you want to add any further counters or histograms or any other details, or any other infos or enums, or you want to set it right, so you can update it here. So once that function is called, the agent metrics is called, basically we are creating these many metrics, we have registering these many matrices. Then we have a set agent state, set agent identity. So whatever the variables we have created, the counters, gauges, histograms we have created, right, I'm giving a set and get methods. So basically set agent state, which will set the state of the agent, and you have to provide the state, whether it is a processing, as I mentioned earlier, right? So the agent state, can have 4 values. So agent state can have initializing, ready, processing, error. So this is the state. So you have to provide the state, so that this will set the enum of that agent state variable. And agent identity also, you can pass some info, and that info will be get set here. I mean, the you can pass any keyword arguments, and I'll create a subject ID. This is a subject ID, and I'll set the keyword keyword key value pairs, and I will set those values here, and that variable will be set for this particular agent identity. And similarly for pre-processing, I have set and increment methods, and for on data metrics, and for tool metrics, and for function metrics, and for LLM metrics. So I have created basically individual functions instead of calling one function and you pass which variable to change or details like that, right? So it's easy for me to understand these functions easily, so I created individual functions. Let's say for this LLM calls, to increment the how many LLM calls did I just call this function, increment the LLM errors, increment the LLM prompt tokens, and I need to pass how many tokens, the how many count of tokens we have, it is there in the prompt token, how many are there in the completion token, how many are there in the total token. So if I send that count, right, so I basically use the reg dot increase, this register dot inc increases nothing but again this primitives from this particular file. So we have basically created two kinds of a file. One is it uses the Prometheus metrics and it creates some primitive functions, and using those primitive functions we are creating some higher level of metrics. So now we need to use this, we need to import this particular agent metrics class, and we need to call this individual functions that is needed. So when you are creating a class, you need to maybe send some namespace, so it will create a HTTP server in the metrics, and then we need to utilize these functions. I mean, yeah, these functions, the bottom functions that you are seeing, you need to utilize those functions to update the values. So let us go to one of the code. uh, Let me go to, since we are taking the tool example, that is a metric demo is the example, so let me just go to the agent code, and also let me go to uh, the tools. So the tools code, so rest remains the same. So I have taken only one tool example, and other two tools also will have the similar things. So right now I'm doing an import utils metric util dot agent metrics, and once agent metrics is I need to initialize it. So agent metrics and namespace is the, I'm creating a namespace. That namespace is nothing but the subject ID, subject version, and I mean subject ID, subject version, and the release tag of the agent. Then I'm creating the metrics, and I'm setting the state to initialize. Self.metrics set agent state to initialize. So now let me just highlight where all I'm using the agent state. So if you see there is nothing else again here, rest remains the same as old code that we had, and I'm creating the identity to something subject ID, and also I'm putting it in a ready state. So all the initialization is over, and now it is in a ready state. So now let me go to on preprocess. If you remember, we have some metrics function for the in on preprocess. So let us see what it is. So I'm starting an perf counter to note on the start time, and I'm creating a tracer variable. So get metrics, get tracer. So with this tracer variable, if you see here, right, so I'm starting a span here. So before that, if you want to record task mapping, we are sending a basically it is not needed now, so it is not needed. And So user task ID, yeah. So you need to pass something known as user task ID. Or if you are not sending it, we are using the task ID. So what is this task ID? It is just like user is sending some identity for the task. Let's say this is my I'm doing on inference, I'm saying task 1. So the user task ID will be task 1. So you have to send this so that whenever you are going to check in your tool, you can use this task ID to check as well, like whether you want to check for task 1, task 2, task 3, or it could be in username also, user 1, user 2, user 3, something like that. So you need to send that task ID. If that is not there, then the system will take task.task ID. What is this task ID? If you have seen our workflow examples, the workflow engine will create a task whenever it is talking to an agent. It will create one random UUID, and that UUID is nothing but the task ID. So based on this UUID also, you can check. Uh, so that's what I'm taking as a user task ID if you are not providing it. So I prefer you provide this user task ID. If not, we are initializing it to some the workflow engine created task IDs. So since it will be very difficult for you to track for which task which is the task ID, so it's better you create a user task ID. So we have two variables here, user task ID and task.task ID. We have both actually. So if you are sending this, we'll have both. If not, both remains the same. So so right now we have a two nested with conditions here. As I told, the tracer has a the tracer that we have created has a context manager, so I can use a with context. So whenever you are with context, it will take care of starting the span, and whenever the span is done, whenever it's exiting the span, right, whenever it exiting that with context, it will go to an exception, and then it will do an finish span. So or a else span. So we are using the context manager. So with tracer dot span, and the span is the function that we have here. The span is the function, and in that we are passing user task ID, subject ID. So two things we are passing. So actually multiple things we can pass. If you see here, the span, the trace ID, the name, the span ID, the parent span ID, and also labels also you can pass. But right now what I'm passing is user task ID and subject ID. Only two things I am passing. If you see the next tracer dot span, I am passing the task ID, and I'm sending some on preprocess function, and also who is the parent ID. The parent ID, I'm taking this particular agent span, so that this the span that we have created here will be mapped to the main parent span as well, because whenever the main parent span is a user task ID, and if you check the user task ID, there can be multiple spans. Let's say this agent is called multiple times for one particular task, then you might have multiple task IDs, but user task ID remains same. So to know for one particular task how many times this agent is called, or what is the duration for each call, how much time is spent. Let's say for when the first time it came, it took only 5 seconds. When second time the workflow manager sends the input to the same agent again, it took maybe 10 seconds. So in order to break that 5 second and 10 second uh, for this particular agent for in this particular task, we have again created a second order the trace as well. So task ID the is used for second order tracer, whereas user task ID is used for a first order tracer. And in the second order tracer, so we'll say that the parent span ID is nothing but agent span, which is nothing but agent span here dot span ID. So it has a ID, and we'll use that span ID as a parent span ID. So, and also this is the description. So here is a subject ID, and here is the on preprocess is the function. So if you see here, there is a name, right? So name is required. So name I am giving it as a subject ID, and whereas here I am giving it as an on preprocess as a name. So then rest all the functions are, this content is same as what was there in our previous examples, but that it is a little bit blotted because we have added the metrics details also. Let's say if user request is not present, so I'll extract the task.job data, that is nothing but a job here, and if there is no user request key in that particular job, then I'm incrementing the preprocess skipped because there is no user request here. So I'm going to skip that, and I'm giving a reason as a missing required key, and I'm sending a user task ID and the task ID task.task ID. So and again I'm just since I need to note down the time as well, right? So I'm calculating the duration. So time dot perf counter minus start time. The start time is created here. So that is nothing but the duration. So I can do an observe histogram preprocess. Duration is nothing but the duration that I have captured, and action here is skipped because uh, this particular function requires a duration as well as the action, and the exception is also required. So action is skipped and exception, there is no exception, and user task ID and task ID is being sent. So similarly, I am doing it for the success path. This is the failed path. So success path and the exception path is also available here. So for success path, increment preprocess total. For skipped path, increment preprocess skipped. And for error path, exception path, increment preprocess error. So and also I'm observing the histogram. So basically 3 times we are calling the self.metrics here, apart from the tracers. So I've explained the tracers, I've explained the metrics, and similarly in on data also you'll be doing it. So in on data, as soon as the code comes to on data, we are increasing on data active tasks, meaning we have one variable active task, and we have increased that particular variable. And also we are putting a state as a processing in the on data, if in case you want to view it. And status is okay. Some variables we are creating it. Action is success. We have created a tracer same as above, and here also same thing. So with tracer dot span, user task ID and subject ID, and span is a task ID. But here, if you see here, it is a on data. Earlier it was a on to process, and now it is a on data. That is the name of this particular trace. And here also parent ID, span ID is the thing what the this particular span ID. So that whenever you search for the user task ID, you will get everything. So what is how much time spent in on preprocess, how much time you have spent in on data. So here again, the rest remains the same. So there is nothing different. Only thing is I have created one function known as call tool using search and execute tool. Or if you have a if you want to do only searching, right, so you can use this function search tool using search API, where this will provide you which is the tool that is being shortlisted for the call for the task. Right now I'm giving a very generic prompt what tool can be used analyze based on this data. So whatever the input data we collect, so I'm asking you a very generic prompt. This is actuation for the LLM. So the LLM will take care of choosing one tool based on the input data. So I'm giving in very generic actuation for the LLM, very generic statement to the LLM. You choose which tool to use for a given input. And the input text is the input, it's nothing but job, and also giving a tool model, so that if the tools requires LLM, right, what is the LLM that they have to use. So that's what I'm sending it in the selected tool model. And I'm calling a call tool using search and execute tool. So let us see this function. So if you go to this function here also, I'm using something with the tracers. So I'm like I've created some variables known as fn status that I'll be later using in the bottom. Whenever I'm dumping that status, right, I'm using that success or exception. So for that I have created one variable, and also I'm creating in tracer variable, and this is not required, you can ignore this. So right now I've created with tracer span, and I'm giving a task ID, and I'm giving a search and execute tool as a name of this span. So task ID is nothing but again basically it is coming from the this function, which is nothing but again task ID only. So let me just check it whether task ID. Yes, so the task ID is task ID, user task is user task.id. So basically we are getting that tracer with the task ID, and also I'm giving a parent span ID as well. The parent span ID is nothing but the user task ID. So I'm creating one tracer here because the higher order is already created here, right? So we have a separate higher order user task ID, then a task ID, and within that, since you are calling this function, again one more tracer you are creating, and this tracer is showcasing the time duration taken for only for this particular uh, tool call. So again we have wrapped everything in this function. So you are doing a search and execute tool, and if in case there is an exception, and you will just give it as an increment the tools, and also you will put them in the finally. So you have a finally here, and you will observe the histogram. So for no matter whether you are in an exception or whether you are in a success path, before returning the finally will be called, and definitely you will dump those data into the duration data into the histogram, whether it's exception or whether it's a success, it doesn't matter. You will uh, dump your durations, and also you will increase the tool call. So tool call is you have incremented. and also you have incremented the error here. So if error occurs, you will increment the error. If error doesn't occur, you are only incrementing the tool call. If error occurs, you are incrementing the error total also, you are incrementing the tool call also, because it is in the final. If you don't want it, you can move it to in this place as well. So this is for one of the functions. So similarly, we have two more functions, which is only for searching the tool, and it's only called by tool ID. If you have a tool ID that you want to call, you can use this function. If you want to search the tool, which is the tool that I want to use, it is just a search, it will not execute it. To search that, you can use this function. So basically, I have wrapped this self.metrics calls within this particular agent code. So similarly, whatever we have done here, we'll be doing same thing in the tools function code also, the tools code also. Since this tools code run inside the agent code, I am using the same file, the util metric util and agent metrics. The files will be available in this for this function also, because it will be also executing in the same place as this particular agent code. So I can import like this, or I can import like this. If you have any issues, you can import like this as well. So basically, it will make sure that the import is success. So and also yeah, so the file is already available, so it will import this metrics, and you are creating the metrics object here. Yeah, the metrics object is created here, and you are giving a namespace as a commit scribe. And in this namespace, so you this namespace is for a local usage only. It will not be like pushed anywhere. This data will not be pushed anywhere. And right now you are creating the tool client, you are creating it, extracting the user task ID and task ID, so that we can use it for our metrics as we have seen it in the agent code. Those two things are definitely required. So I'm extracting it, and if you go down, so wherever the call is happening, right, so you can start here itself, but right now I have used those metrics only during the call of the task. So yes, so in the generate commit function, so if you can see here, I have added the metrics. So let me just search the metrics. Yeah, so prompt token, yes, so the prompt token, completion token, total tokens are extracted from the output of the LLM, and then we have dumped it here. So increment all LLM calls, observe the call duration. So duration is also let me show you the duration variable creation here. Yeah, duration variable is here. So at the start itself we have put maybe start, yeah, start time. So we have calculated the duration. So we have put it in observed duration, and also the total tokens, completion tokens, and total tokens. So this is how we have observed. So we have updated our metrics. So this is in success path, and during the exception, we have again a exception variable, and we are just passing like failed. In either in success case, we'll say it as in success. So you can see here success. In the case of failure, so it will say it as a failed. And for failed, maybe sometime we will give a what is the exception as well. You can see here LLM errors, and this is the exception type of underscore underscore name is a type of exception. It could be value error or any other exception names you will get, right? So that will come here, or else it will be an success only. So this is how we have added the metrics also to the tools code. Since tools will run inside the agent, so the importing of this file is not a problem. So once these files are done, so let us build this Docker. So apart from that, the other tools also have the same content. So let us build it. So let me register it. So Docker building is already done. I'll not do it again. And the files are also uploaded from my side, but yeah, I'll still let me build it and let me upload it. And yes, the tools files are uploaded, and then let me do an deployment of agent. So the agents might have been, yes, the agent creation is done. So maybe this is the agent code. Yeah, this is the agent code. Let me, if in case required, right, so I can check the how it is installing. Basically this agent is having three tools, right? It requires certain it might have some requirement or text is, so it is basically doing the installation. So the pip install of this requirement happens before the agent get is available for serving, so it is doing the pip installations. So right now the agent is ready, and let me register the workflow. To know more about workflows and deploying of the workflows, you have to check our other videos on the workflow. We have separate playlist for that. And before running the input, I have one other file that I want to show you so that I can add it. So in our service grid example, let me go to metric demo. You have a Grafana dashboard.json. So it is basically a Grafana dashboard. So whatever the metrics that you are pushing, I'm just using those metrics and showcasing in a Grafana. So this JSON file will help in such cases. So whenever you create your own, if in case you are creating your own agent, or you want to add something in the agent code, or you want to add, you have added some new metrics, right? Basically this file also you need to modify if in case you want to watch it. So right now, if you don't have not added anything, then modification may be only related to the title here. So you can add your own titles, and also if in case you can change this UUID as well to the something else, because if UUID is same, then the Grafana will complain that this UUID is already taken. So you better change the UUID. And one other thing, maybe task ID. So yeah, it is nothing but yes. So this is the agent prefix. So what is this agent prefix? Is basically what is the agents you have. So if you have 2 agents or 4 agents, so to bring them in a Grafana dashboard drop downs, so you just have to add those agent subject IDs. So here a value, and here is a text. So I'm adding one underscore, so that this the underscore will create a unique representation for rest all things. So you have to give a value and text. You just have to copy paste this, and a colon is required, and let's say 1.0.0, if it is available, you just make it underscore, the same structure. So this is the name of the agent and subject ID and colon, and for version you require, if it is 1.0.0, then you need to create 1 dot underscore dot underscore, and then stable. So once you add that prefix, you can upload this multiple. So right now I have in only one agent, so I have taken the only one agent code. If you have multiple agents, you can create a multiple. So in our next example, we'll show with the 2 agent IDs. So only 3 things you need to change. One is title, one is this number of agents, and the UUID. So only these values if you change, that's more than enough to check all the metrics that you have created. If you have added any new metrics, you just have to change the uh, the uh, panels here. So you have to add some panels if in case whatever you have added a new thing. So you need to upload this. So what you have to do is you have to go to dashboards, so new, and do a import service grid, and then I have a metrics demo, and I'll take this dashboard. So it will complain that same title as this, but let it be there, so no issues for me. And same UID for me, timing it's not an issue, so I'll go with the same UID, and I'll say overwrite. So once it is overwritten, so you can see, right, so there may not some data or some old data might be there. So let me just run my inference. So inference might be going on with the agent. So yeah, agent is doing something here. Yeah, the 2 inputs, maybe it's the first output has come for one particular input. So we are passing a getIf, and the getIf output, basically it has to give some information related to what this getIf is. And then we have passed some log, and it will call the proper tool. What is a tool? Here earlier it was calling the commit scribe tool, and here now it calls a different tool. That tool is log detective school, the tool, the second tool. So third tool I have not executed, so only 2 tools we have executed. So let us just refresh this page. Yes, some data started publishing here. So yeah, it's a Prometheus, let's not worry about that. The user task ID. So if you have sent any user task ID, right, so that I have already in this place. So this is the user task ID 02684, and one other is 2998880. So let me just go to 02688 This is the first task information, I mean first inference I did. So basically you have a pre-processing latency, whether tasks are active or not, total task handle. Since it's a one task ID, in this task ID only one task is handled. Pre-process early exits, no, nothing happened in the pre-process, no errors also in the pre-process. So this is the start of the pod, and you have a pre-process duration, so pre-process step latency. It's in percentile. You have 3 percentiles right now: P90, P50, P90, and P99. Sorry, 95% here. There is no pre-process skipped, so there is no data for this guys. There is no errors also, so nothing here. So how many LLM calls happened? Sorry, the preprocess call happened. Only one preprocess call has happened. And here are again, it's for on data. So on data took around 7.5 seconds or 9.5. Right now it is just the one data it has, so it is not able to capture very well all the variations. So you have to run multiple times. Then only this P50, P90 will come better. So right now with only one data, it has captured those P90, P50s and all. So it is the total on data task it has processed, and how many tools calls it has done. So there is one tool call, and the tool call latencies are also present here. So now the LLM calls, how many LLM calls is done? Only one LLM call. What is the LLM call percentiles is also present here, and what is the total tokens. So here you have the bottommost is a completion token, and prompt token, and total tokens. So the completion token, prompt token, and total tokens. So again, if you see here, right, so it is uh, divided to the the model wise also, like whatever the model you have, right. So if you are second time you are calling a different model, you will get into a different model listing as well, because while pushing we are giving the model details as well, and also we are giving which is that tool. Right now this is the tool. So if you are calling the same tool with the two different models, then you will get two different values for this guys. So this is the content I have for the metrics. And in the span, so you have a, if you can see here, there is a this is the whole span of this particular, this is the subject ID of the agent. The whole span is 7.25 seconds, and in that the on data alone took 7.25, almost all the time it has consumed is the in on data only. Pre-process is very minute, for 958 microseconds. And in this 7.25, if you see, 7.14 second is spent on the search and execute tool only. So this is about the time duration that the agent has spent. And if you see the cumulative agent span, if you have multiple agents only, this will make sense. Right now it is not required, so only one agent is there. So we'll see when it is shown in the third agent. So these are CPU loads, how much the load, CPU load averages of the pod, and also the RAM of the pod. So if you know the pod ID, right? So since I know this is the pod, so you can go to the top, and you can search for your pod as well. So let me just search this. So if you search that, so you will get the details of those RAM usage and all. So CPU usage, RAM usage, you will get into the for that particular pod. And also we have, as like we have a user task ID, I can select agent wide also. Like since one task can go to multiple agents, you can select those agents as well. Here there's only one agent, so all is what selected by default. And if for one agent itself multiple times the workflow engine has called, right, because one task same agent it can call multiple times, so then also you can filter. Right now for this particular task only once it has called, so I have only one task ID. If you have multiple task ID also, you can search with the multiple task IDs. Right now there is no like only one task ID is there. So span here is if you want to again check only this particular spans detail, right, so you can check, select this as well. And here like who the tool, basically the tool or the functions information will be here. Like if it calls multiple functions, you can sorry, multiple tools in invocation, right, so that also you can search here. So only if you, when you select this, only certain things will be getting varied, not all, because certain things doesn't require let's say pre-process, post-process is immaterial of whether it's a span or whether it's a who, doesn't matter. So only those things which requires this data, right, then only they will change. Let's say you have a agent tool metrics, right, so certain on data or something like that. So it's basically a filtering. So you want to do any filtering based on your span, or you want to do anything with the the tool call, so you can do that. So this is about the metrics of the agents and the tools usage. So that's what we can see it in from this particular graph. So let me just stop everything. So basically we have covered the metrics, how to create a Prometheus metrics using Prometheus primitives, and then we created a metrics dot, we have a metrics.py which is already available in SDK, and then we have created a higher level metrics, and those higher level functions of those metrics are called in the agent code and the tool code. And we have seen the Grafana JSON file as well. and that JSON file you need to throw it in Grafana dashboard. So that's it in this video. So we'll see how to do the same thing in the functions using functions examples that we have dealt in our previous videos. So thanks for watching.